Alright, this time around we are going to look at parallel connection of resistors in a given circuit. And we're going to use a schematic diagram to represent what this is all about. So, a diagram such as this, resistor 1, okay, resistor 2, alright, and then resistor 3. Okay, this is simply the parallel connection of 3 resistors known as with resistances R1, R2, and R3. So remember that the letter R represents a resistor, okay, which is measured, whose resistance is measured in a certain ohms, okay? So that is what it means. All right. With this, we now know that resistors can be connected in what? Parallel. This parallel arrangement of resistors in a given electric circuit. Okay, so for us to find the total or equivalent or net resistance offered by these individual resistors, okay, we need to have a specific formula given as force. That is 1 all over RT is equal to 1 all over R1 plus 1 all over R2 plus 1 all over R3. Okay, we are writing up to R3 because we have 3 resistors in the circuit. We can still increase it. We can still increase it to any number of resistors, dot, plus 1 over Rn, okay? We can still increase it to any number of resistors, depending on the question given to us. All right, having done that, so since we have just 3 resistors, whose resistances are known, we can represent this. We can now have a shortened form of this formula, which is 1 all over RT is equal to 1 all over R1, okay, plus 1 all over R2 plus 1 all over R3. Then we stop, okay? We stop at this point because we have only 3 resistors in the circuit. That is all. Something that we need to understand about parallel arrangement of resistors is that current flowing through each of these resistors is not the same. I repeat, current flowing through each of these resistors is not what? The same. But the potential difference across each of these resistors is the same. Just quite opposite of what we had in our previous lesson on series connection of resistors. So we take it as a note. NB note. The first one is current. Is not the same. Current is not the same. All right. That's what it means. Current is not the same in a parallel connection of resistors. Then II, PD across PD is the same. Just very simple. PD is the same. What this simply means is the potential. I've already explained this before, but let me just throw more light on it. Then what this means is that current flowing through each of these resistors connected in parallel is not the same. But the potential difference, PD, across each of them is quite the same. That is it. All right. Having said that, we look at a simple exercise that will help us understand how to apply this formula. So, exercise, okay, maybe 3 resistors we put it this way, 3 resistors of resistances, R1 equal to 2 ohms, R2 equal to 3 ohms, alright? Then R3 equal to 4 ohms, okay? Are connected in an electric circuit. Find or what is their net or equivalent resistance. It's very simple. So recall the formula. You apply the formula. Okay? You apply the formula. The formula remains 1 all over RT is equal to 1 all over R1 plus 1 all over R2 plus 1 all over R3. We are going to stop at R3 because we have only 3 resistors in the circuit. Okay, we now substitute their values accordingly. 1 over RT is equal to, for R1, okay, we have 1 all over 2. That's 2 ohms. Okay? For R2, we have 3 ohms. 1 over 3. Then, for R3, we have 4 ohms. Okay, you can see. Very nice, simple. Then the next thing we need to do is to find the LCM. Okay? We need to find the LCM of that. RT, okay? All that. We need to find the LCM of 1 over 2 plus 1 over 3 plus 1 over 4. The LCM simple means lowest common multiple. The number that 2, 3, and 4 can divide without any remainder, respectively. That is it. So the number is 12. 12. If 2 divides 12, we have what? 6. 6 multiply 1 will give 6. Plus. Then, if 3 divides 12, if 3 divides 12, we have 4. 4 multiply 1 is 4, right? Then, if 4 divides what? 12, we have what? We have 3. 3 multiply 1 will give 3. Okay? So that is it. You can see we are halfway through. Okay? So 6 plus 4 is 10. 10 plus 3 is 13. Yes, 13. So we have 13. 1 all over RT equals to 1 equals to what? 13 all over 12. All over 12. Okay? Alright, so we continue that way. The next thing we are going to do is to make RT the subject of the formula by simple cross multiplication. Alright, when we cross multiply, we have RT is now 12 comes up, 13 comes down. Okay? Alright, that is it. Okay, we have 12 all over 13 ohms. Alright? Okay, so that is it. This is the answer. The answer is in fraction, not in decimal, it's in fraction. Hello, my friends. At this point in time, I'm going to say thank you so much for your time. Please, I encourage you to subscribe to our YouTube channel, Levi Kingsley. Visit our social media handles, Pinterest, Instagram, Twitter, Likey, and so on and so forth. You can as well like our